ഇപ്പം എൻ്റെ കണക്ഷൻ കയറിക്കൊണ്ടിരിക്കാൻ തോന്നുന്നു. ഞാൻ എൻ്റെ സ്റ്റോപ്പ് ചെയ്യണോ? Yeah, Niveda, we can start.
Okay.
Okay. Please give me
gone live?
Yes, we have gone live.
Okay. Greetings to all dignitaries, guests, and delegates with great joy. Eldo, please mute yourself. Greetings to all dignitaries, guests, and delegates with great joy and immense exultation. I welcome all of you aboard to the second day of International Virtual Tech Conclave IVTeC 2020, organized by IEEE IAIEPELS Joint Chapter Kerala, with a much awaited and excited range of sessions. Today's session will begin with a bang by taking the audience through a virtual tour to Kerala Startup Mission. Following the virtual tour, you will witness the technical session on grid modernization handled by Mr. John McDonald, Smart Grid Business Development Leader at GE Grid Solutions. Then we'll have a panel discussion on IES Under 35 Innovators Contest, which will have Dr. Gautam Ram, Assistant Professor at TU Delft University of Technology, Netherlands, Dr. Tayashiro Nozaki, Visiting Scientist at MIT, and Dr. Bharat Balagopal, Secretary of Energy Storage Technical Committee of IEEE IES. And the panel discussion will be moderated by Dr. Bijna K., the Chair of IEEE IAIEPELS Joint Chapter Kerala. The last event for the day is the workshop on usage of TensorFlow in ML applications by the industrious Bhartendra Thakur, Masters in Machine Learning and Computing, Senior AI Engineer, and Innovation Incubator, which is conducted exclusively for IEEE members. Let us begin the dazzling second day of exploring, learning, and experiencing the diverse and wide palette of IVTeC. Once again, greetings to all the guests, dignitaries, and delegates of International Virtual Technical Conclave of IEEE IAIEPELS Joint Chapter Kerala. The most excited event of this conclave, the rarest of its kind, the virtual industrial visit of renowned Kerala Startup Mission facility in Kalamassery. It is a state nodal agency aimed at spreading the spirit of innovation and entrepreneurship. For all those who have so much love and crave for traveling, but got locked up in the house due to lockdown of this widespread pandemic, IVTeC is connecting you to the world through this fascinating virtual IV. Without delaying further, here we are, the IEEE IAIEPELS Joint Chapter Kerala, proudly presenting you the virtual industrial visit to Kerala Startup Mission of Maker Village, Kochi.
Nausif. I work in Kerala Startup Mission. I handle the evangelization and the business linkage part. So basically, there are three things in this presentation. First one is the Kerala Startup Mission live presentation. What we are doing. The second thing is the presentation. One, Nausif. I work in Kerala Startup Mission. I handle the evangelization and the business linkage part. So basically, there are three things in this presentation. First one is the Kerala Startup Mission live presentation. What we are doing. The second thing is the 360-degree virtual tour about ISC, Integrated Startup Complex. And third, we have a Q&A with with you. So I will share the screen. You can see the screen. So you heard about Kerala Startup Mission. Kerala Startup Mission is a government nodal agency for promoting technology-based entrepreneurship towards the state. So you know the advantage of Kerala. So right now, Kerala is the safe place for this COVID-19. The entire globe is struggling. So you know Kerala is the highly literate state. The major advantages. So we are welcoming more startups to the Kerala startup ecosystem. So we have 13 plus years of operational excellence. In 2006, we started Technopark TBI. That's a single incubator. That was in 2006. Then 2007, we got the first non-academic TBI recognized by DST, Department of Science and Technology. We got the Government of India recognition as an incubator in 2007. So we operated as a single incubator from 2006 to 2014. 2014, by end of 2014, we got the Government of Kerala recognition. Kerala Startup Mission Board, Kerala Startup Mission designated as the state nodal agency for the startups. Then end of 2014, Kerala Startup Mission came to the picture. Our head office is located in Trivandrum. We have different offices now. So in 2016, we got the state CM's award for the best startup policy intervention. Then 2018. DPIT is the central agency, Department of Promotion of Industry and Internal Trade. We got the top performing state in India. We got that award in 2018. 2019 January, we officially launched the India's largest startup hub. That's called Integrated Startup Complex in Kochi. And the 2019 November, we got the UBA Global Best Public Policy Business Accelerator Award from Qatar. This is the quick timeline about what we are doing now. You can see the 13 plus years of operational excellence. So the Kerala startup ecosystem today, right now we have 2.62 lakh square feet incubation space. We have in our portfolio 2,500 plus member startups and 750 plus crore fund of funds we are going to disperse. This is every year we are releasing an ecosystem report. Last year, 2019, Kerala ecosystem report released by In42. This is the statistics from that report. So right now our primary focusing to product startups. We have 77% of startups are into product and rest of them into service. This is the incubating, non-incubating ratio. 58% of them are incubated. The other rest of them are into non-incubated. Student and professional startups. Most of our startups are professional startups. Those who have different experience in different domains. And also we have some student startups as well. And the gender ratio, men and women. And also we have different focus area, B2B, B2C, B2G. This is the ratio of our focus area. Our major sector-wise analysis into IT, 45% of our startups are looking into the IT, and we are diverse into all sectors. Anything related to technology, healthcare, EdTech, hardware and IoT. Then 23% of our into different sectors, like energy, smart mobility kind of thing. So basically what we are doing, this is a startup puzzle. We inspire people, educate startups, then launch different products and grow and impact. Basically we are fulfilling the all startups needs. For inspiring, we are conducting different startup summits, like Huddle Kerala, one of India's largest startup summit. Seeding Kerala is an investor-friendly event. Then Shield Out Tech is an event focusing on the women's startups and the different competitions. Then for educating, we have a 230 innovation cell that's called ED Club, IEDC, Innovation Entrepreneurship Development Center, that across in different parts of Kerala, mostly into the engineering colleges, polytechnic and arts and science colleges. So we are giving the fund. Basically, we creating from the schools, then colleges, then startups. Right now, our focusing is into startups. So in schools, we distribute the Raspberry Pi kit program. Then in colleges, we created the entrepreneurship culture among students. So we are managing this IEDC network. So those who are interested in entrepreneurship, they can attend different programs. The particular college have a nodal officer So under that nodal officer, that college will give the support for this kind of entrepreneurship activities. Then last year we did a design summer school in association with CAD. Then we have Fab Academy, electronic school project. These are the different programs we are educating the startups, creating the entrepreneurship culture. Then for the knowledge section, we have Fab Lab. We have 2 major Fab Labs and 20 mini Fab Labs. I'll come across the next slide for the detail about the Fab Lab. Then we have Future Lab. We have idea challenges, innovation zone, and all for creating this thing. Then for the 20, we have 23 plus incubators we are supporting, seed fund support. Then we have innovation grant, patent schemes, different R&D grants also we are supporting. So we are also growing our startups. First, like we have a pre-incubation program, then incubation program, then accelerator, and also we have different market exposure program. And also our startups can like exhibit in different forums, different startup summits, different international business delegation also we are doing for impacting their supports. So for Inspire is like an evangelization part of this technology and entrepreneurship scenario. So as I mentioned earlier, we have a Huddle Kerala. Huddle Kerala is one of the startup summit. That's a tech startup conference happening in September every year. I think due to COVID, I'm not sure about the physical event will happen this time or not. Maybe otherwise we'll go for a virtual event. So last 2 editions we conducted in Leela Palace Kovalam. That's like different sessions. Like it's one of the India's largest startup summits. Around 1,500 participants will gather. Like different sessions happening at same 2 days event, workshops, talks, parallel sessions. Beachside Huddle is one of the interesting section in Kovalam Beach. Then we have another program called IETeC Summit as part of evangelization. Every year we are conducting IETeC Summit. IETeC Summit is the annual gathering of all IETeC colleges in one place. So we conducted 4 editions so far across Kerala. So in this IETeC Summit, more than 4,000 plus like-minded students, they will gather in one same time. We will inspire like giving talks. We will invite the subject matter experts and the top entrepreneurs from across India, and they are delivering the sessions and all. That's called IETeC Summit. The third one is Seeding Kerala. Seeding Kerala is an investor networking program. So we did 5 edition of Seeding Kerala. Last edition was in February in Kochi. So Seeding Kerala is like a investor education program. We educate HNAs, high net worth individuals, to invest in startups. Basically every startup needs funding. So we are creating a investor friendly culture in Kerala. There are so many HNAs are like located in Middle East, Kerala Middle East connection. So we are bringing more HNAs to invest in startups. So that's why we like created this program, Seeding Kerala. So in Seeding Kerala, there are like different HNAs will come, angel investors and also investors as part of our Fund of Funds program. So we will discuss different panel discussion in various topics like healthcare, edtech, medtech, or hardware, IoT, like that. And they will share the experience, and also startups will get an opportunity to pitch their idea in front of the investors. There are like different things happening in Seeding Kerala, that investor networking program. Then we also have IVTeC Women Startup Summit that also conducted last year. That's Women Startup Summit also similar to Huddle Kerala, but focusing into the women, empowering more women startups to the ecosystem. IVTeC is a global competition for promoting like more women to the they want to start something new. So last year we launched this global competition called IVTeC. This year also we are planning to launch this. So these are the like different programs as part of the evangelization part. Then we are educating like different programs, like as I mentioned, like CIID. CIID is one of the world's largest design summer school, Copenhagen Institute of Interaction Design. So we conducted a summer school in different topics. I think after 2018 Kerala flood was the major topic. So the speakers and the academicians come from different parts of the country. They come together and we'll share this, educating this summer school. Then we also conducted the Singularity University Global Impact Challenge. In India, we are the first state to host the Singularity Global Impact Challenge in Trivandrum. Then we have Fab Academy. Fab Academy is like Fab Lab is a lab. It's a prototype lab how to make almost anything from nothing. That is Fab Academy. So we are every year January, like there's a 6-month Fab Academy program. Those who are interested into the 3D printing, CNC cutter, laser printing and all, you can join this Fab Academy. This program are directly run by MIT, Massachusetts Institute of Technology from USA. The classes are like online. You can go through fablabkerala.in website. You will get more idea about the Fab Academy, the virtual course and all. And also the 230 plus IVTeCs in our across Kerala, innovation as part of academics. We are teaching entrepreneurship through this IVTeCs. So this is Fab Lab Kerala network. So basically Fab Lab is experimenting anything with the digital fabrication, like make almost anything from nothing. Right now we have 2 major Fab Labs and 20 mini Fab Labs. 3 months back we officially launched world's one of the largest super Fab Lab facility in Kochi in integrated startup complex. So there you can, the advanced 3D printing machines, laser cutting machines, zoned CNC cutter and all, you can avail this facility, and you want to create some prototype, you can use our Fab Lab facility, high precision machine capabilities, R&D and any other training purpose. Just visit fablabkerala.in website. You can book the slots or course, academy or Fab Saturdays. You can go through that. Then we have a program called Future Technologies Lab. This is one of our initiative. We are experimenting with emerging technologies. Nowadays, the future technologies are like AR, VR, augmented reality, virtual reality. In this COVID scenario, we are like introducing this virtual reality tool. Like we are showing the 360-degree to like video of integrated startup complex, how it's working and all. Then the ML, machine learning, AI thing. The future related all things, we are supporting those who are into the future technology area. We are giving the technology support and the mentoring for startups. Mentoring is one of the key area for any startup they need. So we are creating a holistic AR VR ecosystem in Kerala. So we in ISC we have a different center of excellence. Unity Technology is one of the world's largest game developing company. So in association with the Unity, we are conducting like a different accelerator program as part of Future Technologies Lab. So basically we are giving access to cutting edge gadgets, software, like a different AR or VR softwares, different machines we are giving for testing for related to the startups, and also training and mentoring program from the industry experts. Mostly from Unity and the other from other industries such as like TCS Innovation Lab kind of thing. We are giving this kind of expert talks and mentoring for these startups. Then we have different idea challenges and innovation zones. So it's bridging the gap with the industries. Innovation zone with I think 2 years back we did an innovation zone with Electricity Board, then Kerala Water Authority and Kerala Police. So why we are creating these innovation zones? Like through these innovation zones, even our startups can like exhibit their product, or like they can sell their product through these innovation zones. You know Gen Robotics. Gen Robotics came through Kerala Water Authority Innovation Zone program. Then Kerala Police, they deployed a robot, one of our startup called Asimo Robotics. They developed a robotic called Sayabot. So Kerala Police deployed the KP bot, India's first robotic police robot. in their head office. So through this innovation zone, we are helping our startups, and also we have a different idea challenge, industry startup collaboration platforms. So we throw some problem statements, the challenges. So one multinational company wants to create a product or something, we create some industry challenges. So some of our startups, those who are into like solve that issue, we will connect to the industries through these challenges. So basically what we are creating this idea and challenges is bridging the gap with industries. Then Kochi, we have our presence in like Trivandrum, Kochi, Calicut, Kasaragod, Kannur, and right now Palakkad also we opened an office. In Kochi is the largest hub. Kochi is the commercial capital of Kerala. So we launched in Kalamassery, we launched the Technology Innovation Zone. It's a 13.2 acre campus. In the Technology Innovation Zone, our ISE, Integrated Startup Complex, is located. We launched I think 15 months back. Technology Innovation Zone is a global destination for innovation entrepreneurship. So there are like the different innovation hubs in the world. So this is like Integrated Startup Complex is one of the largest, I think in India, this is the largest innovation hub. So it consists of multiple incubators, accelerators, co-working space, center of excellence, like different things under one roof. That's called an innovation hub. So I will talk about Integrated Startup Complex. So this is the one innovation hub. It's the infrastructure is like 1.8 lakh square feet. It includes residential block, office block, common data centers, technology labs are located in this as part of this Technology Innovation Zone. So these are the different enablers. As I mentioned, we are running our software incubator. So we are managing those who have a software idea. So you can incubate in our like Trivandrum, Kochi, Calicut. We are running a different cohort model incubation program. Then we have sector-based incubators. I'll come to the next slide. Then we have accelerator. Accelerator is the next stage of an incubator. Once you graduated from that incubator, you can go to an accelerator program. From the accelerator, you will get an extensive mentorship, training, demo day, pitching with the investors. They will connect to the different global partners as well. Then in this ISC, we have a different innovation lab, future technology lab, fab lab, and maker space. Right now, we launched the super fab lab facility, one of the biggest super fab lab in Kochi. Not in Kochi, in the world. It's located in Kochi. Then we have Center of Excellence with the Alter Technologies, Unity. So these are the COEs. They are helping. They are the like different industries bodies. They are helping our startups. Then we have different co-working space in ISC. I will go through the like 360-degree video. Then also we set up the different international launch pads in ISC and different parts. We tie up with different governments in different countries. So what we give like in this innovation hub or incubator? So this is the basic question everyone is asking. So we are giving a world-class co-working space. In that 360-degree video, you will experience what is this world-class co-working space. What we are giving a dedicated space for startups. So we will provide a 24 hours internet access, housekeeping facilities, security, and everything in a subsidized rate in this co-working space. Also, we have a different types of mentorship and business development council. In every offices, like we organize different events, programs for networking, peer-to-peer learning, and also for the networking, like different supports we are giving, and different mentoring sessions. So you can go and get the details through our website, social media pages, or mailing. Subscribe our mailing list. You will get no more about our upcoming programs, and you can register for the same. So here we are providing like different networking opportunities and the technology support, and also we can connect with the international market as part of international market access program. You don't need to go to anywhere. Yeah, suppose you are in ISC, Integrated Strata Complex. Every ecosystem enablers like community builders, they are coming to this place and they are visiting our space, and they will have a roundtable meeting with the selected startups for the connect. So we will announce every program through our network. Different mentorship support. We have different financial support. We have a idea grant support, seed fund, and the founder funds. I'll come to the next slide. And also we have a industry connect program. We'll connect to the different industries, private as well as government. These are startupmission.kerala.gov.in. Then I will show you a 360-degree video, like what is this integrated strata complex. So this ISC is located in the Kerala Technology Innovation Zone. So this is the front view of ISC. You can see I am going to the lobby. So this is the main lobby. You can see the infrastructure and all. I'll go through a quick walkthrough. So once you enter in the integrated strata complex, you can we are first entering to this main lobby. This main lobby, there will be a reception desk. You can enter if you are coming as a visitor. You can enter in MyGet application. You can fill the details whom you want to meet. Like there are different departments in Startup Mission. You can enter the details. This is one of our startup product called Bata Save. Right now, Amazon acquired this product. This is an autonomous store, a digital store. These are like we have different conference room and all. So then from the lobby, we are entering, there are 8 floors in this building. We are entering to the workspace. This is a workspace like our office is located. Then we have different workspace. Our startups are working in this co-working space. Like we have a telephone booth, and small conference rooms. Like when startups want to discuss with their team members, they can use this facility. This is like this is the co-working space our startups are working. The plug and play office space. They can use 24 hours internet facility, everything. It includes internet, electricity, housekeeping, security, every facilities. This is the workspace level 1. This is the workspace 2. So we have different like sectors like closed space, open space, co-working space. This is the closed space. One of our company called Riafi Technologies. They are operating this in this closed space. You can see like when startups are discussing in the like different areas. We like shot this video in a Saturday, so that's why very less number of people are. Then we have workspace level 3 in Maker Village. Like this is a dedicated co-working space for the meeting rooms and all. This kind of telephone booth, if in an open co-working space, someone wants to do a private call or like a marketing call, they can come to this telephone booth. So a fully air-conditioned telephone booth, you can like have a phone call from this telephone booth. This is the like co-working space, and this is the amphitheater. We have 3 event rooms in ISC, Integrated Startup Complex. Amphitheater is one of the like an international facility. Like here we conducting different workshops, talks, panel discussion, like different knowledge sessions in a weekly, monthly basis. Like in a month we are hosting 15 programs. This is the second conference room. In this conference room, like we have 200 people can sit. Amphitheater, we can occupy like around 120 seats. So some chairs are like, this is a long conference room. Amphitheater is different. Amphitheater, I think you've seen that amphitheater. Like there's a stage, there's a stage, speakers, and look, people are coming from different parts of they can sit here and we conduct different hackathons, boot camps, ideathons, different sessions. Conference hall and conference this is the conference hall 2. Like we have a 16-seater conference room, then we have a meeting room, we have future technologies floor, we have a video conferencing room. This is like located near to the lobby. Then we have here the office, like our right now we are like giving to our consultants, mentors, so many mentoring hours sessions are happening in this different rooms, different meeting rooms. Then we have investor sessions, investor heights. These are the like different meeting rooms. Even we have a program called Investor Cafe. Every last Wednesday of the month, we are inviting different investors from the country. We'll set up a meeting with selected startups for investors. So these investor one-to-one mentoring and pitching sessions happening in this kind of boards. So you can apply Investor Cafe in our website. This is the like meeting rooms. This is like a 35 seating conference room. Our major industry partners coming, if they are coming, we will conduct these meetings in this 36 seater conference room. Then we have in ISC Maker Village. Maker Village is the dedicated incubator for hardware, electronics, and IoT. This is the old view. Like right now, they shifted to the new space. This is their like old space. So each table represents one startups. These are the 3D high-end 3D printing machines. So they make hardware startups showcase their product. So there's a delegation visit came. So that time we showcased in. So that you can see there are 50 60 tables. Each tables like different startups. We are giving the R&D facilities. These are the startups who showcase. This is Aero underwater drone, India's first underwater drone startups located in ISC. This is Fab Lab. This is an old Fab Lab. Right now we launched the Super Fab Lab facility. So basically, Fab Lab is the digital fabrication lab for creating the prototype. So this is one of the oldest CNC prototype machine. So right now, this video we shot like 3-4 months back. So 3 months back, we launched the Super Fab Lab facility in ISC. So you can see the advanced machines, zoomed. This is some of the like oldest machines. These are the furnitures we created from the Super Fab Lab facility, like Fab Lab facilities. You can see the Super Fab Lab facility once you are coming to the. I'll add to the in this video next time. Then we have the corridor. This is like we have freelancers corner. Even freelancers can come and work here. We have a premium co-working space. And these are the facilities. People they have a one-to-one meeting. And in this corridor, this is the corridor level 2. We have a future technologies lab like Unity, everything like they can when startups into AR VR, they can use this facility, they can avail the space and all. This space is like we are giving for a scale of startups. This is a closed space. Then we have a common area. Even this is like a Copa Cafe model, you know, in Silicon Valley, even that's like a small like cafes. When startups, founders, and the investors they want to like discuss something new, like this is like we built for discussing startup related things. People are working here. Then we have a different hall. We are creating a leave work play model. startups can play table tennis, different indoor games in this hub after they're finishing their walks. You can see goes to lobby and make a and this is the rear view. You came to the front, and this is the rear view of this building. There is a cafeteria here, then food court in the basement floor. This is the rear view of integrated startup complex. You can see the greenery there, fully located in the a greenery area next to the Kamashiri Medical College, Kochi. This is the main view of this building. And we have one more incubator is also going to launch, that's called BRIC, India's first cancer incubator. Is now it's going to launch in next 1 or 2 months. That also locating in this integrated startup complex. Then we have Bionest. Bionest is like 200 meters away from this ISC integrated startup complex. This is the main front view of the Bionest. You can see, and we also started the construction of the phase 2 of the building, that in the Kerala Technology Innovation Zone. You can see the construction. That is one of the largest building, total around 5 lakh square feet building. We are building built up space. This is the fully, you can see there are in Bionest, there are different bio labs, the fragmentation labs, the testing. These are the advanced machines for the scientific medtech. This kind of labs are on different rooms. I just got the one image. Okay, this is all about.
Sir? Sir, are you here?
Yes, can you hear me?
Yes, it's audible. Sir, can you share your screen?
Yes.
It's good.
Although we can start right
Yes,
after
yes.
the conclusion, right?
Yeah. Right
Okay,
after
okay.
conclusion.
And a small info about sir.
Yes. Niveda, you can conclude.
Okay. Thank you, ladies and gentlemen, for your time and patience. We are extremely privileged to have you all here today. Furthermore, we appreciate your valuable time and patience for witnessing the virtual industrial visit to Kerala Startup Mission. I would like to express our sincere gratitude to Kerala Startup Mission authorities for giving us this fascinating virtual tour. I also thank all the dignitaries and the delegates of IVTeC for making this such a grand and memorable one. The technical session on grid modernization by John McGowan will be commencing in few minutes. Stay tuned in the same channel, guys. Thank you and have a great day.
Sir,
Yes.
you can start sharing your screen. No presentations visible.
Right. Okay.
Yeah, I'll set up.
Eldo, are we live?
Yeah, we are live.
A warm welcome to all the delegates. It's a pleasure for us all to be here at International Virtual Tech Conclave 2020, conducted by IEEE PELS Joint Chapter Kerala. For this session, we are privileged to have Mr. John D. McDonald, the Smart Grid Business Development Leader for General Electric's Grid Solutions business. Mr. McDonald has 46 years of experience in the electric utility industry. His contributions to the industry and to the IEEE society is endless. Moreover, he is the past president of the IEEE Power and Energy Society and the past chair of IEEE PES Substations Committee. He has published over 150 papers and articles in multidisciplinary areas. Apart from this, he has co-authored 5 books and also has a US patent. The feathers on his cap are innumerable. And today, he will be sharing his knowledge with us on grid modernization, the technological advancements beyond smart grid. Without further ado, I invite Mr. McDonald for a session on future transportation and energy. Sir, please.
Can you hear me okay?
Yes, sir.
Yes, sir, it's fine.
Hey, well, listen, thank you very much for the opportunity to participate. I've been very involved with the Power and Energy Society. I welcome participation with your joint chapter, and I will show you some power electronics applications in my talk, as well as some industrial electronics and industry applications, okay, for your joint chapter. So I've been an IEEE member 49 years. Next year will be my 50th year of membership, and been very active for 49 years, okay? And I'm an IEEE Life Fellow.
Right, sir.
So I've worked 46 years full-time, and my work has been in automation of the electric power system. That's my specialty with my books and my papers. So what we'll talk about is the electric grid. I've also been married 40 years, have 2 children and 2 grandchildren. I teach at many universities, and I exercise regularly with a trainer. So I feel as you get older, it's very important to have a balance between your work and your life. Okay. These are the key topics I'll talk about. I'm going to reference some articles that I've written. I may reference some of my books. And if you want any copies of those articles, please let me know. My email address is after my name. It's johndmcdonald@ge.com. And you can send me an email and ask me for copies of any of the articles, okay, or information on the books. Okay? So, no matter whether you're in power and energy or whatever you're doing today, what's most important is we've transitioned from components or devices or systems to what we call holistic solutions. And I will show you examples of holistic solutions in a few slides, okay? Success is also technology, standards, and policies. So it's not just technology, but industry standards are very, very important today. We're typically, with these solutions, we're putting together components from different vendors, and they have to be able to communicate with each other. And the only way that will be successful is with all the vendors complying with the same set of standards for communications and exchange of information, okay? With everything that we do, we want to incorporate self-healing. We like our technology to be able to detect a problem. On the electric grid, we say a fault, but it could be a problem. Detect it, locate it, isolate it, and restore service around that faulted area, okay? We call that self-healing. It's very important to have a resilient system, okay? Resiliency means the ability to withstand the stress of an external event. With the electric grid, it could be extreme weather events, right? A tornado, a monsoon, earthquake, you know. How can we design in reliability and redundancy to be resilient? I'm also going to talk about data. We're putting more sensors out in the field, and we're getting a lot more data. How do we manage that data? Our automation systems are using the cloud to a greater extent. We have what we call system components that are cloud-based. And we're also using social media to a greater extent. When a customer has a problem, instead of using the phone, we prefer the customer to use, say, Twitter, and send a tweet of outage information to the electric utility. And we can intelligently parse the keywords of the tweet, extract the outage information, and automatically put that into what we call the outage management system. And then what's very important is to bring together the IT, or the information technology, and the OT, the operations technology part of the electric utility. Bring them together, bring these two groups of people working together to support what we call enterprise data management across the entire utility. So one of the things that we want to differentiate is we've been adding intelligence to the electric grid for many years. Me personally, I've been doing it for 46 years, okay, for a long time, and 49 years in the IEEE. What we've been doing in the past is shaded in light gray. We call that the old grid. The new things we're doing are in light green, smart grid additions, okay? And we want to compare here what we're doing new with what we've been doing previously. Voltage on the electric grid is directly proportional to the load. If I control the voltage, I control the load. So the new thing that we're doing here is we're integrating voltage control with reactive power control. We call that VOLVAR control. So that's what this is. Here we're integrating sun or photovoltaic panels and wind renewable generation into the grid. These are special sensors here that we're adding to the grid to give us more special information. The reason is we're moving from reactive maintenance to predictive maintenance. We used to wait until something failed and then we would fix it or replace it. Now we don't want to wait until it fails. We want to be better. We want to predict the health of that piece of equipment. Okay, so we have special sensors we're using that give us health information on a continuous basis. Special analytics we've developed that analyze that information, and we can detect a failure mode occurring before it actually occurs and prevent, say, what we call a catastrophic failure, a complete failure of the piece of equipment. We also are putting in special computer-based control systems here to manage the increasing complexity of the distribution part of the grid. This is the part of the grid that brings the electricity to the customer, to the home. And when we integrate renewable generation into that part of the grid, it becomes very complex. We'll talk about that. We're also adding what we call distribution automation. We're automating the feeders that bring the electricity to the customer. And we've been adding a lot of smart meters, okay? I mentioned integrated solutions, holistic solution. The word holistic here means across the whole customer. Right? In other words, holistic meaning enterprise-wide, across the entire customer organization. So we have 6 holistic solutions. A solution is a set of technology components that are integrated together to meet the business needs of the electric utility. First is asset optimization. And the most expensive asset on the electric grid is a transformer. Okay, so a transformer is over $1 million US. Okay, so it's very expensive. We don't want to have that fail. We want to be able to detect failures. So we have special equipment that we add to the transformer. It gives us health information on the asset. Second is circuit breakers, okay? We call that switchgear. So we have special equipment we add to tell us the health of the circuit breakers. Second is demand optimization. We can take load, customer load, and we can aggregate that, and we can use that as a dispatch tool in the utility control center. Okay, that's a very good tool to use in it, but it's doing this is very new. Third is smart meters and two-way communications to get the metering information up to the utility. Fourth is distribution optimization. This is adding intelligence to the distribution part of the grid, right? This is the part of the electric grid that brings the electricity to the customer. We're also adding intelligence to the transmission part of the grid, right? So we have the generation part, which generates the electricity, the transmission part, which transmits the generated electricity long distances to get closer to where the customers are, then the distribution part of the grid, and then the customer itself. And then we have workforce and engineering design optimization. We have to focus on the workforce because in the energy field, we have many, many experienced people that are retiring, okay? So we're doing a lot of things to attract young professionals to power and energy. For instance, when I was the IEEE PES president in 2006 and 7, we surveyed many university students, and we found that we asked them, what are the 3 most important things with your first full-time job when you graduate? And the first one was, I want a job that helps the environment. Second, I want a job that helps society. And third, I want a job that pays me good money and that I live in a location that I desire, okay? So we found that the environment and society were very important. So in 2008, we changed the name of our power. At the time, we were the Power Engineering Society. We changed the name with IEEE to Power and Energy. And by adding the word energy, we emphasized helping the environment, helping society. And with that change and emphasizing society and environment, we've attracted many, many young professionals to the Power and Energy Society, to PES. We're now the second largest society in all of IEEE with over 40,000 members. Okay, we're second only to the Computer Society. So we really emphasize helping the environment and helping society in general with our technology. So if we take those 6 solutions, this is the technology roadmap of those solutions. In the upper left here is the control center and the office part of the utility. In the lower left are the substations. Lower right, these are the equipment on the feeders, the distribution feeders that are downstream of the substation that bring the electricity to the customer, okay? Let's look at just one of these integrated solutions. Let's look at distribution optimization. That's light blue. So if we look at the light blue boxes, this is software applications and systems here in the control center and the office. Here we have the station controller. We have applications. We've distributed the intelligence from the control center down to the substation. So we have a lot of intelligence here at the substation level. And then this is equipment that we've added on the feeders downstream of the substation, okay? So think of all these light blue boxes could be from different vendors, different suppliers, but they all must interoperate, right? They all must be able to successfully communicate with each other and exchange information with each other. That's why industry standards are so important, which I'll talk about in a minute, okay? Now, what's very important today is microgrids and distributed generation. This is where we get into industry applications, the Industry Application Society. Also, we get into industrial electronics and power electronics, okay? Now, The distribution part of the grid, when we initially designed it, we assumed that electricity would only flow in one direction, from the source down to the load, okay? But when we integrate distributed generation into the distribution part of the grid, what it causes is electricity now flowing in two directions, from the distributed generator upstream, and then from the source to the load. So it gives us a lot of challenges. Two-way electricity flow, which we didn't initially design for, and some other issues that we'll talk about, okay? Now we can integrate distributed generation into the transmission part of the grid, distribution part of the grid, or at the customer's home, right? By putting photovoltaic panels on the rooftop. What we'll talk about now is the distribution part of the grid and the end user. So some of the challenges that we face are open circuit over voltage due to unintentional islanding. A microgrid could be operating connected to the grid, but if something happens to the main grid, we want the microgrid to continue to operate, so it may island itself. It may disconnect itself from the main grid. Well, if it's unintentional, if we didn't plan for it and it islands itself, we may have an open circuit over voltage condition. Also, protection ratings of the protective relays may not match fault currents because now we have a component to the fault from the load, from the distributed generation, okay? The problem too is that the fault currents due to the distributed generation vary. You know, the sun doesn't shine the same all the time and the wind doesn't blow the same. So there's intermittency with renewable generation, which causes the output to vary, right? So a lot of challenges. This is a microgrid that we installed about 5 years ago at GE in Canada. You can see that there's industrial and residential load. This village the village was not near an electric utility. It was very rural, out in the country. They had their own fuel cells, they had their own photovoltaic panels, they had some hydro generation, but their base generation was diesel. Now when diesel operates, it sends carbon dioxide to the atmosphere, right? It pollutes the atmosphere. So we wanted to minimize the diesel generation and maximize the use of these distributed resources. So we added logic here to a microprocessor-based relay to make that a microgrid controller. The objective was to satisfy the load continuously and to minimize the use of the diesel and maximize the use of the distributed generation, okay? Now, one of the challenges with distributed generation is the intermittency, right? The load needs to be satisfied all the time. How do we satisfy the load when the sun isn't shining on the photovoltaic panels? Well, we can use batteries, right? Energy storage. That's instantaneous. Or we can use what we say fast start, fast responding thermal generation. And typically this generation uses natural gas as its fuel because it's lower cost and has lower emissions. So we have new technology today, which is fast start, fast responding natural gas turbine generators. And then we have pre-packaging of, say, lithium ion batteries to help with, again, with instantaneous needs or system frequency to deal with the intermittency. So we have new technology solutions today, both with energy storage and with natural gas-fired turbine generation to help meet the intermittency of the renewables. Okay. Now, this is a special article I wrote in 2013, almost 7 years ago, in Power Electronics magazine, okay? And it was new applications of power electronics. The new applications were driven by the impact of the high penetration of rooftop solar photovoltaic panels on the distribution system. And I used a specific example from a utility in California, San Diego Gas and Electric. They had one distribution feeder where over 35% of the homes on that feeder have rooftop solar panels. That's a very high penetration. What happens is in the morning, these homes were on the ocean, on the Pacific Ocean, and there was a marine layer of fog caused by the humidity of the ocean that blocked the sun from seeing the photovoltaic panels on the roof of the homes. When that fog burned off later in the morning, all of a sudden, all of these homes began generating electricity instantaneously. The voltage on the feeder spiked. It had a step function increase and then spiked and then oscillated. Sometimes the clouds would be between the sun and the rooftop solar panels. The challenge was there's a mechanical controller in the substation, and it's supposed to keep the voltage, the secondary voltage on that feeder constant. Why? Because in my home, I don't want the voltage to be changing all the time because my light bulbs would be very bright, very dim, very bright, very dim. This tap changer, as the secondary voltage changes, the tap changer changes tap settings. Each tap setting is 0.5% of volts. And it automatically changes taps to keep the secondary voltage constant as the primary voltage changes, okay? These are mechanical. So the more they operate, the more they have wear and tear. Their expected lifetime decreases as the duty cycle increases. Well, when we have high penetration of rooftop solar PV, the variability, the volatility in the voltage increases exponentially, which means that the number of operations of the tap changer increase exponentially. This tap changer on this feeder in San Diego was expected to have a lifetime of over 35 years. Now, with this increased volatility, its lifetime is less than 2 years, okay? Less than 2 years. So I wrote this article and I said, we need to convert these tap changers from being mechanical controllers to being power electronic controllers, power electronic based. So we have researchers now building, designing, developing prototypes of power electronic based online tap changers. Also, we have a new family of devices called low voltage network dynamic grid edge controllers. These are power electronic set point controllers that we install on the low voltage part of the network. In other words, right outside somebody's home. And what they do is they do set point control of the voltage and reactive power to smooth out that volatility caused by the high penetration of the distributed generation. We also are adding much more functionality into inverters. We call these smart inverters. Okay. These are all power electronic devices, low voltage power electronic devices. And my point is with researchers at universities and with companies like my company, GE, get the power electronic experts working more closely with the power system experts, because we have new applications of power electronics in the electric grid. Okay, very, very important, and a good example for you to show why you want to have a joint IEEE chapter. Okay, we don't do industrial electronics by itself. We don't do industry applications by itself. We don't do power electronics by itself, and we don't do powered energy by itself, right? We need to bring the expertise of these societies together, and this is a good example, okay? Now, because of the increasing complexity of the distribution part of the grid, electric utilities are adding a special computer-based control system that we call Advanced Distribution Management System. The way we monitor and control any automations application is through a SCADA system. SCADA is an industry term that means supervisory control and data acquisition. We're acquiring data from the field, and supervisory control means remote control. So one of my 5 books is called Power Systems SCADA and Smart Grids. I wrote this book with a professor, Minnie Thomas. She's a professor at Jamia Millia Islamia University in Delhi, India. Okay, Minnie is a very close friend of mine. She is now has a 5-year assignment as the director of the NIT in Trichy. Okay, she's originally from Kerala. She and her husband Shaji are from Kerala. But she and I spent 2 years and we wrote a book about SCADA, about transmission SCADA, distribution SCADA, which is this ADMS, and substation SCADA, which is called substation automation. So in the control center, we have this ADMS, Advanced Distribution Management System. We have this basic platform which acquires data from the electric grid and provides remote control capability. And then we have very special applications here where we model the distribution part of the grid and have this special analysis here to optimize the operation of the grid. So we need to get information from the field, substation and feeder devices. That comes into this computer platform. We analyze it, and then we send control commands back out to the field to do the optimization. Okay. Now we can distribute the intelligence of some of these applications down into the substation level, which is what I showed with those light blue boxes at the substation level. So there's a lot of different applications, special applications on the ADMS. These are the applications that the operators in the control center use continuously in real time. Okay, they do very special optimization of the different parts of the grid. Now, in the IEEE Power and Energy Society, I teach a 1-day tutorial just on this, on an ADMS. Okay, now let me say this too. The 1-day tutorial is 5 PowerPoint modules that we use. During this COVID-19 pandemic, when many people are working from home, the IEEE Power and Energy Society is offering this 1-day tutorial for free, okay, to any IEEE PES member. You can go to the IEEE PES Resource Center. You can find my tutorial on ADMS. And each of the 5 modules, once you sign in with IEEE, and once it verifies you're an IEEE PS member, you have access to all 5 modules. You can take the 1-day tutorial for free. It's one of the offers that the IEEE PS is making during this time when more people are working from home. This is another set of applications. These run on the ADMS, but these are more used for analysis, so they're on demand. They're not being used continuously, but they're special analytical tools. And then we have another set of applications which are based on the utility. These are additional applications a particular utility wants to run on the ADMS. So you can see it's quite complex, but it does a lot of optimization of the distribution part of the grid. So with any utility today, the trend is they want to go from doing things manually to being a fully digitally enabled grid. So we call that the digitized grid. That's what the utility's goal is to be a digitized grid. But you can't go from the bottom here, where you are today, to the top to be fully digitally enabled in one step, right? Typically, it's too much effort and too much money. So what we typically do is we help a utility say, let's put a roadmap together, a strategy. So let's say you're starting here, which is manual control and legacy methods. And let's add special equipment called circuit reclosers. Let's add special intelligence with trouble call and automated metering infrastructure. This is smart meters and two-way communications, and a SCADA system here with remote control and monitoring. And that has a big benefit. That lowers what we say customer minutes interrupted. It lowers outages by 28%. Okay, let's continue and add even more intelligence. This is automation and visualization. This is outage management prediction analysis, network visualization tools, and what we call distribution automation. Okay, the special applications on an ADMS. Now it's 43% lower customer minutes interrupted than the base level. And then we may get to the fully digitally enabled grid, which is even more intelligence, and that's greater than 50% benefit in lower customer minutes interrupted. Okay, this is the real world. This is what we do in the real world. We say, where are we today? Where do we want to go? And how do we get there in steps? But at each step, we want to have significant benefits back to the customer. Okay, here's another approach with making sure that the money we invest has the biggest benefit. Here's a utility with 856 circuits. These are the distribution feeders that bring the electricity to the customers. Okay, this is a pretty big utility, 856 circuits, and this utility wants to improve their reliability. They want to implement intelligence. Well, we don't want to implement intelligence on all 856 circuits. That's a lot of money and a lot of work. How can we still have a lot of benefits, but not spend that much money? So let's analyze these circuits. And in analyzing the circuits, we found that if we look at just 23% of the circuits, 200 of the circuits, they account for 71% of all the outage minutes of that utility. Okay, this is very important. So if we automate only 200 of the circuits, just 23%, we're addressing almost 3/4 of all the outages that utility has. That's significant. That's getting the most benefit from the money that you invest. So by doing a deeper study, we can do a better job of getting more benefits from the money that we spend. Okay? Now, when we install equipment in the field, whether it's industry applications or power electronics or whatever it is, we want to make sure that we're extracting the data that has value from that equipment and making sure that the right people at the customer get that data so that they can provide the most benefits to their organization. There's really, in a microprocessor-based device, there's really two types of data. There's operational data and non-operational data, okay? The operational data is the information that we send to the control center, and it's what the operators use to monitor and control the power system. Very important information, and it's a time series of information. You know, what is the voltage now? What is the voltage in 2 seconds, in 4 seconds, in 6 seconds? So every 2 seconds or every 4 seconds, we're sampling this information and sending it upstream, okay? So it's a time series of information called operational data. But with the introduction in the 1980s of microprocessor-based devices, suppliers include a different type of data called non-operational data. This is both points and files. This could be a digitized waveform. It could be a sequence of events report, which is a file of information. We don't need this continuously. We just need it on demand, okay? And the operators in a control center typically don't need it. That's why we call non-operational data, but other groups in the utility need it. Could be the power quality group, could be the asset management group, could be the maintenance group, and it's very important information. There's as many as 25 to 30 different groups in the utility that need this information in addition to the operators. So here's some examples here of dissolved gas in the oil of a transformer, or the moisture content in the oil of the transformer. We have special sensors that give us that information. The contact wear of the circuit breaker contacts in the substation. We have special sensors that give us that. You know, maintenance needs that information, not the operators in the control center, but maintenance. Or digital fault recorder records. These are digitized waveforms that are needed by the protection engineer. Okay? So we have both operational and non-operational data in the same device, the same microprocessor-based device. So you want to extract, we want to first identify which of these points has value to somebody in the utility, extract that, and make sure that we send that information to them. The operational data is time sequenced, as I said. It's real time or near real time. And it's we send that upstream with a standard non-proprietary communications protocol, but industry standard. The non-operational data, as I said, is a data file or points. It's mostly historical, and we may have to use a vendor-specific proprietary format to get that, to extract it and get it upstream. So one of the biggest things that's happening today that I'm sure you all have heard about is the Internet of Things. Sometimes we call that the industrial Internet of Things. So it might be IoT or IIoT. We're bringing together intelligent machines with big data and analytics and with people at work, no matter where those people are, okay? We're connecting people any place, any way, and any time. The idea is that we want you to have all the information you need when you need it without having to go get it. It might be in your Google glasses, okay? You look at your Google glasses and you have the information you need. So this is what we're doing today, and we're leveraging this to provide more benefits in power and energy, okay? So what we want to do on the left here is we want to bring all the different groups in the electric utility together. Each of these groups today has its own systems, its own microprocessor-based devices, and its own databases. And we want to break the silos down. We want to make sure there's data sharing across the company, across the utility. And we can do that with a federated data mart here. And then we bring together all the systems, all the devices, all the databases, and we share the information, okay? The idea then on the right here is that all the different data sources at the electric utility, we've identified all the important pieces of information, we've extracted it, and all the different users here in green throughout the electric utility have the information they need, okay? Now let me say that in 2003, I wrote an article in IEEE Power and Energy magazine that introduced this concept to the industry in 2003. If any of you want a copy of that article, I can send it to you. But this is how, these are industry standards today. And this is how we approach getting the most benefit from the data that we have in the electric grid, okay, in the enterprise. So what we're doing today is we've moved from reactive, in other words, wait for something to happen and then we react to it. We want to be more responsive, and today we're predictive. We're determining what health information we need to extract from an asset, like a transformer or a circuit breaker. And then with special analytics, we're predicting the health of that. And if we see any potential problem, we address it right away. But we're from predictive, we're going to prescriptive and eventually autonomous. We're using machine learning today and artificial intelligence and the concept of a digital twin, which is using physics and the characteristics of that asset, we're modeling that in software. Okay, it's a digital twin. It's a software twin of the actual piece of equipment out in the field. Okay, it's really exciting. I wrote the first chapter in a new book called Big Data Application in Power Systems. Okay, this whole field this is the journey to the digital transformation. We're hiring data scientists now at GE. Electric utilities are hiring data scientists. There's much more emphasis on data, analytics, and flexible dashboards than there ever was. Okay, there's tremendous benefits, and this is part of becoming a digitized grid. Okay, now I mentioned standards are extremely important. On the left here, in 2010, a group of us developed the Smart Grid Conceptual Reference Model. It's 7 domains and how those domains interact with each other. But what's most important is I've been involved with industry standards for about 30 years, okay, leading standards in IEEE. There's over 100 smart grid standards in IEEE and over 100 in IEC. We went through all of those and said, these are the 16 most important standards with smart grid. These are the foundational standards with smart grid, the ones that I've listed here. This helps the industry. You don't have to go through hundreds of standards, but this helps the industry determine which, if you're at a university and doing research, which standards do you need to focus on with your project? If I'm developing a product at GE, which standards do I need to incorporate? If I'm an electric utility and I'm buying equipment, which standards do I need to make sure are incorporated in the equipment that I'm buying? Okay, very important. Now, what's neat is in the industry is if one control center is talking to another control center, one utility talking to another utility, there's one global standard today for that communications, which is our goal is to have one global standard that everybody uses. Okay, from control center to field, there's two global standards being used. One by North American suppliers in the US and Canada, and one from European suppliers and the equipment that they develop. Then in the field, there's really 2 global standards, but the most important one is IEC 61850. That is the true global standard here for substation automation and protection. So what we've done is over time is we've converged on much fewer standards, okay? It makes it easier for the industry to choose. Now, after 18 months of deploying smart grid projects, we learned a lot at GE, and we said, what are the lessons we've learned? I wrote this as an IEEE Smart Grid newsletter in 2011. It's on the IEEE Smart Grid portal. But we learned that standards were extremely important. The 2 key words today with everything that we do is integration and interoperability. We also learned that testing is important. You want to do a lot of testing before the equipment gets to the field. We also learned that an organization needs to have a smart grid roadmap, like I showed previously, and a strategy across the whole utility. We learned it was very important is for a project to be successful, in addition to having very, very sharp engineers, we need to have very experienced project managers, okay? The project manager is just as important as the technical people, the engineering people. Project management is extremely important. These projects become very complex, and we need to have consistent project management guidelines, okay? They come from a program management office. The utilities roadmap is governed by a corporate steering committee. So any ideas for new projects, that idea needs to be consistent with the overall strategy, the roadmap of the utility with respect to smart grid. And then we found out that the residential customer, the end use customer, is a major stakeholder today. When we put a smart meter on your home, we need to make sure that we explain to you the value of that smart meter, okay, and the new services we're providing. let me finish because I want to make sure we have time for questions. There's a free IEEE Power and Energy Society webinar that's available to all of you, okay? And I spent time looking over my 46-year career, and there were 12 key decisions I made in my career that influenced the rest of my career. If you know that information early in your career when you're younger, you can do a better job of managing your career, okay? And I provide all this information in a 1-hour webinar that was recorded by the IEEE Power and Energy Society, and it's offered to you for free, okay? It's called Key Insights to Career Management, and it's available at no cost. And all you have to do is go to the IEEE Power and Energy Society Resource Center, search on it, either by the title or my name, and click on the link, and you can see me, you can hear what I have to say, and see all my PowerPoint material. Okay, so it's your career is your career, and understanding your priorities, which will change in your career and your company's objectives, will help you to really manage your career and make the best of the choices all throughout your career. Okay, so I really, if you can, take advantage of this webinar. And if you have any questions afterwards, again, send me an email. I'd be happy to help you, work with you, and answer your questions. So with that, I'll finish, and thank you. And
thank you, sir. Would you be willing to answer a few questions now? Hello?
Please read out the questions.
Yes, sir. There's a lot of hardware infrastructure and cost involved in grid modernization. How can we address this problem? By Ruby Rubin.
It's not really a problem. It's more of an opportunity for us to add intelligence to the grid and make the grid, safer, more reliable, more stable. So it's exciting to us that we're applying new technology to the grid, and this new technology could be hardware, right? It could be devices. We call these, the IEEE term is Intelligent Electronic Device, or IED. We have new hardware devices. We have new communications. We have new software applications. And what's exciting is these don't just stand by themselves, but we integrate many of these together into what I called an integrated solution. And that the integrated solution really provides the most benefits to the customer, to the utility. So it's really an exciting time for us because technology is changing very quickly, and we're taking advantage of that and developing a lot of new things that really make life better. They help the environment, they help society, and they make the grid more intelligent and do a better job of bringing electricity to the customer.
Thank you, sir. The next question would be, what would be the efficiency and contribution of transparent solar panels into the grid in future? And there's a similar question, impact of electric vehicles on electric grid, and how can smart grids help in this?
Well, what's interesting is the cost of photovoltaic panels has really gone down substantially, to the point where we say, in English, we say there's parity. There's parity, there's equivalence between the cost of solar generation and the cost of, say, coal-fired or oil-fired generation, of thermal generation. And we actually, last year in the United States, we implemented more solar generation. And actually, the load was satisfied by more thermal generation by solar generation than thermal generation. So we reached a point where, because the cost of solar has gone down so much, there's much more solar being used today than thermal. Okay. Now, electric vehicles will create, increased load, right, on the grid, especially the distribution part of the grid. And what we need to do is we're adding intelligence to the grid. We don't want the electric vehicles to charge at the time that we have a peak, right, in the grid. When people get up in the morning, there's a peak, and when people come home from work, there's a peak. So what we want to do is we want to charge the electric vehicles overnight when the load is lighter. So we add intelligence to grid and different charging scenarios to delay charging, to even out the load curve, and to prevent a peak getting worse. So there's intelligence that we're adding to the grid.
Okay, sir. Then last question would be, moving to automatically working circuit and connected internet with it, what about the security issues on these circuits?
That's a very, very good question, because cybersecurity and also privacy of information is something that's very important. And what we've learned is when we develop new technology, we need to incorporate cybersecurity from the very beginning of the development. You can't wait and be halfway through a development and then start thinking about cybersecurity. So we have, I have a PowerPoint slide, for instance, it's the secure development lifecycle. It's how we incorporate cybersecurity into every step of the development of new technology. Okay. Also, with smart meters, we need to make sure that the information about your electric usage, your personal usage, is not sold by the utility and is not made available to other companies. Okay. That we call that privacy of information, and there's very specific rules and regulations regarding privacy. So these are all things that are very important to us, and they're all important considerations and implementations in the smart grid technology that we do.
Thank you so much, sir. On behalf of IVTeC team, I would like to immensely thank Mr. McDonald for taking his time and giving us a very clear insight on grid modernization. As a token of love and gratitude from IVTeC team, we would like to present you a virtual memento. Sir?
Thank you. Yeah, I want to thank you for the opportunity, but also I want to emphasize, if anyone has needs for information, on articles or books or things, please send me an email. I'd be happy to see what your comments and requests are, and I will respond to the information you're looking for. Okay. So thank you again.
Thank you very
Most
much,
definitely,
sir.
sir.
All right. Bye-bye.
Bye. Once again, up the next session is under 35 panel discussion.
So our team, Dr. Gautam and Dr. Bharat has joined.
All three of them are there. I saw all three.
Nasaki is also Nasaki also joined, right?
Gautam, hi.
Hi. Oh, Nasaki. Hi, Gautam. Hi. Hi.
Hi, hello, I'm Bharat.
Bharat.
Hi.
Bharat.
Hello, Dr. Bharat.
Hi.
And
Hi. Nice to see you.
Dr. Takahiro. Hi. How are you?
Take care.
Hi. Dr. Nasaki. Hi.
Hi.
So shall we start with the formal
Yes.
introduction?
Yes.
So we are ready, right? So shall we start?
Oh, shall we
Yes,
start?
sir. Yes, sir.
Yeah, of course. Yeah.
I hope you are having a great time at IVTeC, and I hope you are enjoying the diversity of events we are presenting to you. Moving on, next we have the most awaited and engrossing session of the day, the International Virtual Tech Conclave 2020, organized by the IVTeC PELS Joint Circuit Kerala, presents you the panel discussion as 35 innovators. We are very much graced that the panelists are the winners of the Under 35 contests organized by IS and EMS. Knowledge is power, but is power multiplied. Our panel
Naina is facing technical issues, sir.
Yeah, Naina, network issues.
Convenience cost. Yeah, I'll take it over.
Yeah, Niveda, please take it.
Greetings to one and all. I hope you are having a great time with IVTeC, and I hope you are enjoying the diversity of events we are presenting to you. Moving on, next we have the most awaited and engrossing session of today. The International Virtual Tech Conclave 2020, organized by the IEEE PELS Joint Chapter Kerala, presents you the panel discussion by the Under 35 innovators. We are very much graced that the panelists are the winners of Under 35 Innovators Contest organized by IES and TEMS. Knowledge is power, but the knowledge shared is power multiplied. Our panel discussion today will be moderated by Dr. Vijna K, the professor at PKM College of Engineering, Kollam. And ma'am is the chair of IEEE IAIE PELS Joint Chapter Kerala and has been an active part in the conducting of IVTeC. Ma'am, I request you to take over the session. Please, ma'am.
Good day to all. Good day to all. It is indeed my pleasure to be interacting with the younger section, and which makes me also even younger. We are about to hear from the innovators who have proved themselves as under 35 also. They are nothing less and more than what the greatest scientists could offer to the world. Let me introduce all the three speakers to you first. To start with Dr. Gautam Ram Chandramouli. He is currently the assistant professor at TU Delft University of Netherlands. I have seen him as a graduate from NIT Trichy in the year 2011, and then shifting to TU Delft for the rest of his education, his master's, his PhD, his even postdoctoral fellowship, and then right now with the university as a faculty. He has been quite attached to our IEEE and IES also, and he is currently the vice chair of IES Benelux chapter. Indeed, it is my pleasure to welcome Gautam to this panel discussion.
Yeah, thank you for inviting me.
Thank you. And the second speaker that we have, Dr. Takahiro Nozaki. It is indeed a greater moment for us to have you with us in our panel. He has been working with Keio University, Japan, and he has been instrumental in developing an intelligent robotic arm at the Haptic Center there. And he is currently a visiting faculty at the very prestigious Massachusetts Institute of Technology, the MIT. It is my pleasure to have you here with us today for the panel discussion. Welcome, Takahiro Nozaki.
Thank you. Nice to meet you.
Our third speaker, Dr. Bharat Balgopal. He is also another person who has graduated from Amrita Vishwavidyapitham, Kerala, India, in fact, 2011. And then he has moved to North Carolina University for his future studies. And he is also another very good associate with IEEE, being the secretary of the Energy Storage Technical Committee right now. And he has various other positions that he has held in IES during this tenure. It is indeed our pleasure to have you also here for the panel discussion. Welcome, Bharat Balagopal.
Nice to see all of you.
Yeah. So as a first round in the panel discussion, we would like to hear from you that you have all emerged as winners of the IEEE Innovator Under 35 Contest of IES in the last year. So first, we would like to hear from you. What was the innovation which has made you eligible for this particular position? So we'll go with the same order, starting with Dr. Gautam Ram for his presentations. Welcome, Dr. Gautam.
Thank you very much for the introduction. I've now made a short presentation, which I will share with all of you, which highlights in a very broad sense what was the innovation that I had worked on here at Delft University. And later on, we can take some questions from the audience after everybody's presentation. Okay, I will just share my screen. Can you see my screen?
Yes.
Yeah. Okay, you can see the first slide.
Yes, we have.
Okay, so the topic I would like to talk to you all is about a solar-powered electric vehicle charger that I worked on during my PhD and also developed in Delft University of Technology together with our industrial partners, PRE, Last Mile Solutions, ABB, and University of Texas. So what you see here is a picture of a fossil fuel power plant which is used for electricity production. And in the bottom right, you see a picture of a Tesla electric car. So if I ask all of you in the audience, what would you like to see in the future? I'm very confident that all of you would say that you would like to see the electric car in the future. Nobody wants to see fossil fuels being burned and emitting carbon dioxide as we move many years into the future. But the reality today is that it is these fossil fuel power plants, powered by gas and by coal, majority, which are now actually producing our electricity. And using that electricity, we are now charging our electric vehicles. So as much as electric cars themselves have no emissions due to carbon dioxide and other harmful gases, the electricity production continues to have these emissions. So what I would like to see in the future, which I think a lot of people all around the world and the younger generation wants to see, is a future where you can use renewable sources of energy like solar and wind to produce our electricity, and then we can use that electricity to charge our electric cars. So to put that in context, if in this graph, what you see here on the left axis is the grams of carbon dioxide equivalent which is emitted when you make 1 unit of electricity, 1 kilowatt hour of electricity. Now what you see is just depending on which country you are. On the left side, you can see in Sweden, it only results in 13 grams of carbon dioxide being emitted. But on the other hand, if you look at other countries, for example, in Germany, in Poland, in Estonia, and you see in India, you see that the amount of emissions because of producing electricity is much higher. You see like something like 700, 800, and even 900 grams emitted from 1 unit of electricity. So this means that electric cars are not yet as sustainable as we go into the future as they actually can be. So if you're in Sweden, it's hardly any emissions. But if you're in Estonia or India or Poland, you have significant amount of emissions. So what does this mean? So this means that what you see here again in this graph, which is from the Joint Research Center in Europe, you see that in the bottom, you see different countries which are indicated. And on the y-axis, you see the grams of CO2. If you use this for driving 1 kilometer with the electric car. What you see here is that if you're in a country, you see those two lines for ICE, internal combustion engine vehicles. So if you're in a country where the emissions from electricity production are very high, then you might even end up in a situation where your electric car has more emissions than using a gasoline car. When you look at the whole greenhouse gas emissions from a well to wheel, right, from taking out the oil or the coal, refining it or producing the electricity to driving it and actually doing 1 kilometer distance. So the key message is electric cars must be the future, but we should use sustainable source of electricity for producing our electricity. So which means the technology that we worked on for this innovation was to use solar energy for doing this. So what can you do now? So let's say that you want to use solar energy for charging electric car. What you see here in this picture is you can buy a solar inverter. You can buy a standard electric vehicle charger, and you can use this to basically take energy from the solar, transform it using an inverter from the DC to the AC, and then you can use an AC electric vehicle charger and you can charge your car. But there is a little bit of a catch to this. And that is, if you see the energy produced in solar panels, it is direct current or DC, while the energy in our grid is alternating current or AC, and the energy in a battery is also DC. So what we are now doing is we're taking energy in DC, you're moving it to AC, and then we're moving back from AC into DC, which means you have this unnecessary power conversion which leads to losses. You need this inverter. So what we focused on was what we call as an integrated DC solution. So what you do here is you use one charger which works fully on DC, which takes energy on DC from the solar panels. It is what you see here. You can take energy on DC from the solar panels, and then you can use that energy on DC to charge the electric car. And if you don't have enough solar energy, you can then take energy from the grid for charging the electric car. So why is this solution considered to be new and state of the art? And that is because, one, you have this DC integration of solar and electric vehicle, which means you have much higher efficiency. And we only need one inverter for both the solar and for the electric car for exchanging energy with the grid. And if you make this charger bidirectional, you can use the electric car also as a storage for the solar energy. So which means you can store extra solar energy into the electric car. And when you need that energy, then you can send it back from the electric car to the grid. And also how we design the system is that you can do 4 operations using this charger. So one, you can take the energy from the solar panels and put it into the electric car. What you can also do is that if there is no solar energy, you can take energy from the electricity grid and charge the car, or send energy from the car back to the grid. And in case there is no electric car, you can take the energy from the solar panel and send it to the grid, just like what a normal solar inverter does. Also, we focus in this project on using wide bandgap semiconductor devices based on silicon carbide. So what that means is that you can have much higher switching frequencies in your system. And also we used powdered alloy core inductors. And this makes what you see in this pictures on the left side, you see a 10 kilowatt or 10,000 watt solar inverter, you see a 10 kilowatt electric vehicle charger. And what you see is that the developed solution is much more compact. So you see it's about 3 times smaller. And it's not only smaller, if you look at the efficiency, what you see here in this graph is you see the efficiency point in the solid lines of the developed converter, and you see the efficiency in the dotted lines of the conventional system based on AC. You see that the efficiency is either comparable or much higher, especially at lower powers. Especially when you charge from solar, you're not always having the full solar energy. You often have partial powers. So you get much higher energy efficiency at partial powers. And you see that this system is compatible with CHAdeMO and Combo, which are the 2 global standards for electric vehicle charging. So we also develop intelligent charging algorithms. I think in the previous talk, John was talking about how we should do smart charging, and where we should look at the grid situation, and we should look at the congestion in the grid. We should look at energy prices and how you should intelligently charge. We also develop such algorithms within this project. And what you see here is that through these algorithms, you can have a drastic reduction in the charging cost, because it's trying to see what's the best moment to charge the car and makes a scheduled planning based on solar generation, based on the congestion in the grid, based on frequency regulation. So this is really about the technology part. I also think it's interesting to look a little bit on the kind of a real world application. So what you see here in this picture is expected increase in the demand of these kind of bidirectional chargers. They're called as vehicle to grid chargers, which are 2-way chargers. And you see that as we move forward from 2020 to 2030, it's expected that this market of using the car battery as a kind of a potential for grid support is going to dramatically increase, which means that you can use this electric car battery for things like frequency regulation for the grid, for energy trading in the grid based on the prices, and you can use it for congestion management in the grid, and you can also use it for backup power. So imagine that there is a certain few hours where the grid is down. You have a big battery inside your car, and it can provide power for you for weeks, because these car batteries can be 50 kilowatt hour or 70 kilowatt hour. So there has a lot of potential in using this vehicle to grid technology in the future, and it can also result in a lot of revenue. So there's been research which has shown that up to $8,000 in revenue can be got. But also there are cases where the revenue was found to be zero. So this also means this is something which is very interesting from a research perspective to see what's going to happen in the future with this topic. So I would like to finish this presentation by mentioning that we not only did a project within the Delft University, but we also work with industrial partners, so which means that this charger is also now commercially available, that you can buy it and you can install it. And this is going to be a big project also in the UK, where this charger will also be used as one of the options in this trial for vehicle-to-grid technology. In terms of key USPs, if you look in the bottom picture, you can see the kind of chargers that are currently available, which can do this kind of vehicle-to-grid functionality. And what you see here, these are like really big chargers which have to be installed. And while the solution that we made, which is on the picture on the right, is much more smaller wall box. So it's a very compact and lightweight solution. You can use it with solar, you can use it without solar, and it operates on DC, which means it has high efficiency, and it can use the car battery as a storage. You don't need an extra battery for storage. And from a price perspective, it's like buying a solar inverter and a car charger, but everything combined into one. Therefore, it's a much more cost-effective solution than buying these systems separately. So we got a lot of awards for this project. So one of the awards was the most significant innovation in vehicles award, which was the best tech idea of 2018 award from the magazine Type. And when we also applied to the under 35 competition, we were very fortunate that we also were one of the finalists together with the other people presenting in this panel. I would like to finish with this last slide. If you are very interested in electric vehicles and you would like to know more, we have a massive open online course. It's a free course on the IVTeC platform on electric cars. And I, together with other professors, we give lectures on electric vehicles. We have 4 courses: Introduction, Technology, Policy, and Management. And so, if you're interested, please do go to IVTeC and follow this course. Thank you very much. If you have any questions, I'll be happy to take them later on.
Thank you very much, Gautam. We would like to hear more from Takahiro Nozaki. Dr. Takahiro Nozaki, please. Well, Dr. Ram was talking about V2G and CV. Now, Dr. Nozaki will be talking us from brain to hand.
Let me share my screen. Can you see my screen?
Yes, it is coming.
Okay. Okay.
Yeah, we can see your screen, yeah.
Okay. Okay, then let me start my presentation. Hello, everyone. It's my great pleasure to talk to you in this wonderful conference. My name is Takahiro Nozaki, and I'm an assistant professor at Keio University, Japan, and I lead a research and development team as a principal investigator. I have succeeded to realize many innovations in industrial solutions and products by haptic technology. So today, I will show you the results and introduce some future possibilities. Maybe you do not notice that all of you adjust applied force by using sense of touch in your daily life. Without the sense of touch, you will easily break the target object, since you cannot recognize whether your finger is touching the object or not. Therefore, a sense of touch or tactile information is very important and necessary, especially in contact motion. So, in contrast to the conventional clumsy and dangerous robot, we can provide the market with dexterous and flexible system. And we call our haptic technology as real haptics. This technology called real haptics was developed originally in 2002 by Professor Kohei Onishi at Keio University. Let me introduce the basic principle of our technology. All of you know an electric motor rotates if current flows. And when the motor makes a contact with the object, load force is applied to the motor. By estimating the applied load force, we can obtain force information without using conventional force sensors. The conventional force sensors have a lot of drawbacks in robustness, cost, size, and bandwidth. This technology enables transmission, storage, and reproduction of tactile or haptic information by utilizing the estimated load force applied to the motor. This will dramatically improve sophistication and automation of working processes. Let me introduce some of the examples. The first one is the dual-arm teleoperation system. This dual-arm teleoperation system can transmit visual, auditory, and haptic senses. So the image the operator is watching is exactly the same as the image the robot is watching. And also the sound is transmitted from robot side to the operator side. And the operator can feel the actual stiffness of the target object through the robot. So the robot can hold the cup with adequate force so as not to crush the cup and also not to drop the cup. With this robot, dangerous work in extreme environment can be performed safely from a remote location. So as you can see, maybe this video is a little bit choppy, but you can see this robot can realize this kind of dexterous manipulation. The second example is prosthetic hand with haptics. She doesn't have her own right arm, but in this picture, she is using our prosthetic hand. And the sense of touch detected by the prosthetic hand is transmitted to the device mounted on the big toe. This is the experimental movie. This is conventional myoelectric hand. She couldn't manipulate the potato chip because she couldn't feel how much force is applied to the potato chip. But by using our haptic prosthetic hand, she succeeded to manipulate the fragile potato chip because she could adjust the grasping force. And this is another video from another view. By feeding the applied force through the device mounted on the big toe, she could manipulate, or she could realize this kind of dexterous manipulation. Next example is avatar fishing. Now this is the avatar fishing that enables sheep fishing from downtown area. The user can view the actual force caused by the fish, and the operator can see the seaside area. And we succeeded to conduct actual verification experiment, and we could catch fish that in Oita while in Tokyo. The Oita prefecture is far from Tokyo, and the distance is about 1,000 kilometers. This is a robotic manipulator for extravehicular activity in space, which is collaboration with JAXA. And this is a remote work system using 5G communication and Pepper, which is a product of SoftBank Corporation. This example is the application for the hydraulic-driven excavator. The operator uses the glove-type master system, and the excavator tracks the position of the glove, and also the grasping force is transmitted from the excavator to the operator. And we mounted this system onto the actual excavator and succeeded to realize this kind of dexterous manipulation and succeeded to manipulate the fragile material. This is a real-time discometer utilizing our technology, our haptics. From the estimated force information and the velocity information, we can estimate or we can get the physical characteristics of the liquid. We are also developing a high-performance motor drive system dedicated to real haptics. An automatic full sorting system. So today I introduce some of the innovations which I realized. Today I don't dive into the detail, but these are the market size of each applications, and the total market size is really huge. So I believe the world changes with human-friendly motor drive technology. These are the reference, but ideas. That's all. Thank you for your kind attention.
Thank you, Dr. Zaki. In fact, this was very interesting to see your research. Maybe most of the spectators or all those participants who are here would be really interested in knowing more about it. Right now, I would like to hear more from Dr. Bharat Balagopal. I think he is going to talk more on the storage rather than putting it to the grid. Welcome, Dr. Bharat.
Hi, everybody, and hi, Gautam and Takahiro. It's nice to connect with y'all again. It's been a while. So let me jump right in and share my screen. You should be able to see it right now. Yeah?
Yes, sir, it's visible.
Yeah.
Great. So good morning, good afternoon, good evening for people in different time zones. I am Bharat Balagopal. I am going to talk about smart battery gauge for continuous battery condition assessment. So a brief introduction of myself. I am a postdoctoral research associate working with Dr. Mo-Yun Chow at the North Carolina State University at Raleigh, North Carolina. So what is the purpose of the smart battery gauge? So we are addressing the pain points of the utility market, which is spot checking, which means that they do annual or semi-annual checks once or twice a year. They go out to the field to check their batteries and see how good they're working, which involves a lot of maintenance cost, labor cost, and replacement cost. So in order to avoid those kind of costs, we have developed the smart battery gauge for continuous battery condition assessment. So what is the value proposition? What value is the smart battery gauge adding to the end user, right? So we are able to accurately assess the battery condition when the battery is in use, constantly provide live status update about batteries without any downtime, and able to perform plug and play into customers' battery systems and is chemistry agnostic. So we heard John talk about the smart grid and about how energy storage and renewable energy is going to get so important or is so important. And then Gautam spoke about the EVs and the batteries in the EVs integrating into the grid, right? So V2G and G2V. So all of them kind of tie back into the energy storage system. How can we properly use the energy storage system to maximize the potential of that device and to maximize its involvement while ensuring the return on investment? Because some of these devices are in the orders of millions of dollars. So, depending on the size of the batteries that you're planning to buy. So we need to make sure that we get the money that we invested in, right? So renewable energy, why are batteries so important? Because the renewable energy devices are growing so fast. There's a rapid growth, right? And batteries act as an energy reservoir. So when there's a lot of generation and low demand, the energy can be stored in the batteries. And when there is low generation and high demand, then the energy can be released from the batteries. And this is when you're talking about renewable energy, because you cannot control how the wind blows or how the sun shines, right? So to be able to adjust those intermittencies in generation, these energy storage devices can play a very critical role, right, as reservoirs. So here we have two graphs, which you can see there's almost a 10 times growth in the PV installation and 100 times growth in the entire generation of renewable energy being used, right? So this is getting more and more important in the future. So we need to be able to use these renewable energy devices effectively. And for that, we need energy storage systems. And to be able to use your energy storage systems effectively, you need a smart battery gauge that can continuously monitor the battery and provide live feedback. So the renewable energy market as of 2015, that's 5 years ago, and it's increased a lot more since then, is at 31.5 million units, about $60 billion, and is expected to grow to 51.5 million units, or more than $100 billion by 2025. So for every battery unit, we can install one smart battery gauge. So that tells you how much there is scope for this particular market. And, there is so much need for batteries. And so there will always be need for a proper monitoring device, right? So that's why the smart battery gauge is a very important product. So what can the smart battery gauge help you to do in terms of saving money? Besides having all the features of being able to monitor and provide live feedback, what can it do, right? So the maintenance cost for energy storage devices over a year can be up to $2.5 billion. This is projections are global. So just by doing annual and semi-annual checks, it takes a lot of money to take the system offline, do the checks, and then put it back. And this kind of check requires extended downtime. So if the batteries are disconnected from your operation, then they are not being used. If they are not being used, then that's money that you're not making, right? So $2.4 billion a year is the cost associated with just the maintenance of the batteries that are being used. And high early replacement cost of $1.1 billion a year. More often than not, most utility companies, the data storage companies, they all replace their batteries every 5 to 7 years, no matter what condition they are in, because they are not sure what those numbers that they get from the batteries mean, right? So to be able to give them that information, to tell them, hey, this is how healthy your battery is. You can continue using your battery for the next 5 years without having to worry about it, is valuable information, which can save them $1.1 billion a year. And high labor costs. So that's $5.3 billion a year. Every time you have to go send a person out, because most of these sites are remote sites. They're not in the middle of a city, right? They're somewhere in the outskirts of the city. So every time you have to send a technician or a maintenance crew to go and check it, it takes a lot of time, fuel, money to do that, to pay those people to go and do it, and then to train and test everything. So that costs up to $5.3 billion a year. So without using the smart battery gauge, you're almost spending $8.8 billion a year just to maintain, avoid replacement or labor costs. So using the smart battery gauge, you can save up to $6 billion a year, because we're able to provide constant monitoring of the battery, avoid early replacement, and reduce the labor and testing costs, right? So we've been working on this smart battery gauge for over 15 years now. It started all the way in 2006, and right now it's reached the place in the technology development stage where we're almost at the commercialization phase. right? We're able to take it from the lab into the real world and make a product out of it. So how does this technology work? So we've seen a lot about the market and about what is the need for the smart battery gauge, but how does it work? So we have two main frameworks that make this algorithm. So we have the abnormal data filtering framework and the co-estimation algorithm. The abnormal data filtering framework is something that is very critical to this entire smart battery gauge, because in the lab, everything works hunky-dory, no problem. Everything works fine. But when you take it out in the real world, sometimes there's communication loss, there is data loss, there is incorrect data, there is noise. So how do you filter out all of this bad information, right? So like sensor drift, missing data, transient filters, so all those peaks, how do we make sure that those don't affect the working of the algorithm? So we developed a abnormal data filtering framework that takes the voltage and the current from the battery and eliminates any kind of abnormal data and then sends it into the co-estimation algorithm, right? So if you take a battery, it's a closed system. All you can do is you can measure the voltage, the current, and the temperature of the battery. There is no other information that you get out of the battery, right? So all your modeling, your assessment, your information should be based using these three variables, your voltage, current, and temperature. So the co-estimation takes the voltage and current of the battery and is able to provide an estimate of the state of charge of the battery and the state of health of the battery. So the state of charge of the battery tells you how much charge is left in the battery at that point of time as the ratio of the total amount of charge that it can hold. The state of health of the battery tells you how healthy the battery is, which is often used to determine, when the battery needs to be replaced. So the state of health is calculated using multiple indices. Usually they use the capacity of the battery. So the current capacity of the battery divided by the capacity of the battery when it was new is usually an index used to define the health of the battery. So we use the RC circuit model to reflect, to model the behavior of the battery, as you can see in the top right corner over here. And then using that model, we identify a state space model. So we convert the circuit model into a state space model at the bottom left, where we identify the output and the inputs and the states based on your circuit diagram. And from there, we use an adaptive observer that observes the states of the battery, right? So the states of the battery are the open circuit voltage and the voltage drop across the RC pair in the circuit diagram. So the open circuit voltage is the VOC. So we use the VOC and the VRC as the states of the battery to identify the performance of the battery, because we know that for a particular kind of battery, the voltage, the open circuit voltage and the state of charge have a constant curve. The curve doesn't change, right? So we use that to identify what the state of charge of the battery is accurately, rather than doing Coulomb counting or integration methods where it would probably cause errors because of incorrect initial conditions or a lot of noise in the measurement data, right? So to avoid all of that, we use an observer to observe the states and then identify what the open circuit voltage of the battery is. From the open circuit voltage of the battery, we can work back towards the state of charge of the battery using the VOC SOC curve, right? And then we have another observer that we use from the open circuit voltage of the battery to calculate the capacity of the battery. So we've implemented our smart battery gauge in two real-world facilities. Duke Energy is one of the biggest energy suppliers on the eastern coast of the United States of America. So here you can see that the smart battery gauge has been implemented in their facility. And if you look at the, maybe the next one gives you a better better view, you can see that the smart battery gauge has only two cables connected to it, one for power and one for communication. So it does not need any kind of direct connection with the battery, because most of these batteries come with some kind of communication already installed, right? So with just a communication cable and a power cable, the smart battery gauge is very easily integrated into any existing or new battery system. So that's why we call it plug and play. So this is at another facility called NCMC, so North Carolina Electric Cooperative. So this smart battery gauge was implemented in their facility, and this one was installed in Duke Energy's microgrid facility to monitor the batteries in real time when it is being used. So I have a small demo of how the smart battery gauge works. So you can see here, this is the battery in the microgrid, and you can see it opens up and it has its own user interface that shows you how much charge is left in the battery, how healthy the battery is, and what is the voltage and current of the battery at this instant. So all of this automatically is running. So you can see the voltage being measured, the current at that point of time was 0, and then the state of charge is getting to the value that it's supposed to converge to, right? And you have the health indicator using the resistance, the health indicator using the capacity of the battery. So you're always able to monitor the status of the battery when it is in use, rather than having to take the battery offline. And this is monitored remotely, right? So you don't even have to send your crew to the monitoring site to do any kind of testing or analysis on the batteries that are being connected at the site. So in conclusion, we've developed a smart battery gauge for continuous battery condition assessment that can identify the charge in the battery, the health of the battery, and the life of the battery when the battery is in use, and continuously provide accurate feedback. So again, I'm Bharat Balagopal, and I am a research associate at North Carolina State University. I'll be happy to answer any questions you have after this.
Thank you, Bharat. Thank you, Dr. Bharat. And we've heard of what their innovations are from all the three. Now I want you to tell these participants what has driven you to this contest also. Like some of them will be thinking that the innovations that can be brought out as a result of your doctoral thesis or maybe postdoctoral thesis, only those can be put in for the innovators contest. So is it so? So I want each one of you to just give in a minute a short description of what drove you to this innovators contest, and whether or what preparations should our participants take for that. We'll start in the same order with Dr. Gautam to start with.
So in my case, what happened was I was planning to go to the IVTeC conference, and I understood that this contest was also happening. And what was very interesting was that they were specifically looking for more like a real world relevance for the work that you were doing. And compared to other contests where you would write an application, here they wanted you to make a video of your innovation and how it works, and more demonstrates its application and relevance. And I found it quite interesting, and I gave it a shot.
That's very good, because once you can, because there are so many students, even the undergraduate students, who do it with their hands, but they may not be able to prove it scientifically with their mathematics. So are they checking out the mathematics also at the contest?
Is it also for me, or is that for the other people?
No. For you only, you said.
They didn't go into that details, at least in the application. We had to make a short video, and we sent it, and there was a short description we have to write. So, but it wasn't a detailed mathematics and scientific publication. That was not the focus here. This was about what's the application of innovation, what is the relevance of it. So you can see Takahiro's, this application helping people, and you have remote access. You can see Bharat's application with respect to the relevance for energy storage systems. This was my impression of their focus, and this is what I also try to focus in. That we have this electric vehicles, and you have this context of moving to sustainable energy, and how is that your innovation plays a role in this?
Right. Thank you, Dr. Gautam. Dr. Nusaki, yours is one of the greatest thing that is advantages for humans, especially with those people who have disabilities, differently abled people. For them, it is always good to have such a discovery. This innovation of yours is really marvelous. Now, what drove you to this contest again? Dr. Nozaki?
Oh, what does it mean? Sorry.
No. How did you come to know about this contest, and how did you participate?
It's hard to answer to the question, but I just wanted to present what I did, and as you know, the lectures or classes are just input. We can get many information, but we will not change the world by getting degree or taking classes. So I want to tell the people who will try to the contest, please try to change the world by changing something, and that will be called as innovation. And please just show what you changed.
Thank you. You have actually given a great discovery and helping out people with difficulties. In fact, you can even further think about people who are autistic. For them, mostly they cannot estimate the depth, the strength with which that they should pick up things. Maybe your discovery will be helpful for them also. Great. Thank you for bringing such a great discovery. Again, back to Dr. Bharat. Can you tell me what drove you to the Innovators Contest?
So for me, it was about the technology, and I felt like this is something that people should know about, and because especially energy storage is something that is gaining a lot of interest these days, and innovation is not something that needs to have an impact on everybody. Even if it has an impact on a small part of the population, it still has an impact because it's kind of like a ripple effect. So as long as you're able to change the world, even like one person at a time, this whole smart battery gauge for me was about helping people know what's going on in their world better. And if I was able to do that, then I was like, okay, I need to share this with the world and share this knowledge. Most of us go into education in the hope of sharing knowledge with other people. So that was one of the main reasons why I decided to participate, to share the knowledge that we have something to contribute to the world. So that's one of the reasons why I participated.
That's great. That's nice to hear from you. Hello, student team. Do we have any questions? Maybe we can spend another 5 minutes for the questions if there are relevant questions. Hello, Niveta, Naina. Do we have relevant questions?
Yes, ma'am. Yes, ma'am.
I think Naina, Naina, your voice is breaking.
Okay, yes, sir. We have a question from Anusha Ashish Kurian. How come this be useful, affordable, and available to common people? Or is it focusing on big companies only? Its field of application. Ma'am?
To whom is this question?
It's a question asked in general. I think any of our speakers could answer this.
Because it's all,
Yeah.
it's very tough.
Okay, I'll read it again, ma'am.
Yeah.
How come this be useful, affordable, and available to common people? Or is it focusing on big companies only? Its field of application, wherever are these most useful?
Is it V2G or battery? I think it's better, can be answered by Bharat. Dr. Bharat can answer. This is a smart battery gauge. Can we use as individual users?
So yes, it definitely can be used, because in the end, if you looked at the images that I showed, it was a Raspberry Pi, which is maybe like $30, which would be about 2,000 Indian rupees to buy and install. So the hardware infrastructure required is not particularly complex, and I know most of the time, at least in many Indian houses, sometimes we have inverters. When we have power shortage, we flip to the inverter. So with that, if you're moving from lead acid battery to lithium ion battery, or even if it's lead acid battery, you can still know how much charge is left in the battery instead of just hearing an alarm go off when it's low on charge. That way you'll be able to use your battery better. So this technology has been developed for any usage, household usage, industry, it doesn't matter, because it's not about the hardware, but it's only about the software. I'm sorry?
It has already been brought to the market.
So we are working to, so right now we're focusing on the large scale energy storage market. So with the industries, big battery companies and things like that, because the consumer electronics industry is already packed with a lot of competitors. So we want to establish, I'm sorry?
All the best to commercialize it.
Thank you.
Yeah, Niveta, next question.
Sir, we have a specific question to you from Divan Akhtar. What will be the cost of smart battery gauge? An approximate cost if it becomes commercialized,
That's what he said, rupees 2,000.
That's a very interesting question. It becomes a debate between altruism and capitalism. So maybe for the household usage we could keep it a lower cost device, and for industry we could milk them so that we compensate for the affordable prices for the everyday people. So it's we've not reached that point of pricing just yet, because our focus is only on the large scale energy.
Accuracy and price, we can always go for comparison and do.
Yes. For us,
we're. Any more?
Yeah.
No, ma'am.
Vidya madam?
Thank you very much. Yeah, Biju, yes.
Yes. You know, I think Gautam or Bharat can answer. Basically about the contest itself. What are the various stages in the contest process, and how about the evaluation process? So could you please elaborate on that? My question clear?
Was it about evaluation of the project?
Yeah, first about the various stages in the competition.
You said
you some screening, something like then final, something like that.
You had a video presented.
It's for my question is for the rest of the audience also.
For the contest was quite short. We submitted the videos and a short description, and then we were informed that you were selected. So there were not many stages. It was just one submission, and then we got rolling. And 4 of us were selected. I think there was also we are also had a colleague from Belgium who was also there.
Yes.
4 of us.
Yes, so
is it always selected along with this IECon conference? Always is it like that?
I'm not sure. Did you know,
Yeah.
Bharat?
This particular program was first introduced with IECON. They may do it every year, but it's only for IECON, not for other. Because IECON is the Industrial Electronics Society's biggest conference every year, so they usually host it. But from what I've seen this year, they don't seem to have that because of the coronavirus and all of that. I think I'm not sure because they've already decided to go online. So it was mainly a first time thing that they did last year for IECON. Yeah.
Thank you.
Okay. Thank you very much, all the three panelists. Indeed, your energy might have motivated so many other people also to move into the innovations and moving more and more into EV, V2G, and the robotic arms. Of course, you have really motivated even me also for doing such research. Thank you very much. Indeed, it is my honor to thank each and every one of you. And we would like to present you with virtual mementos also. So starting with Dr. Gautam Ram, we would like you to accept our memento as a token of our appreciation. Students team, please present Dr. Gautam Ram.
Yes, ma'am, it's loading up.
Thank you very much for inviting us, and also thank you, Bharat and Takahiro, for joining me.
Thank you so much.
Yeah, it was very nice to talk to all of you, and good luck to all the innovators out there, and thank you for having all of us here.
Thank you, Dr. Nozaki. It was indeed a pleasure to listen to you. This is Gautam Ram's memento. Thank you. Please accept it. Thank you, Dr. Nozaki. Your memento is coming up. Takes time to load. Thank you very much, Dr. Nozaki and Dr. Bharat. It was indeed a great experience to us also. Yeah. Dr. Gautam. Next,
Please load the second
Second memento.
Dr. Nozaki. Yeah, here it is. All three of you, Dr. Takahiro. Thank you very much for joining us.
Bharat also. Next we have
Thank you, Dr. Bharat. Indeed, it was a great pleasure having spent so much of time with you. And it's all the best from our side also. Continue to be good researchers and please do visit us also whenever you can, whenever this pandemic is over. Please do visit India. Do come to Kerala. We are indeed really happy to host you as we have our IES chapters also coming up at several colleges. We have very good chapter, good membership. Thank you. Thank you all. Thank you, participants. Thank you, student team.
Thank you very much.
And feel free to reach out to me if you have any questions. I'd be happy to help out.
Thank you, Bharat.
Thank you. Thank you.
Bye.
Thank you.
Thank you, Dr. Gautam Ram, Dr. Bharat Balagopal, Dr. Takahiro Nozaki, and Dr. Bijna K for putting up such an excellent and enthralling discussion. We had a great time listening to you. The panel discussion was both informative and inspiring. A bit more formal version of the IVTeC will be happening next. Thank you so much for all attending the session. This concludes the events for the day, and next we have a workshop exclusively for IEEE members. Those who have registered for the workshop are requested to check the mail. Thank you all. Have a great day.
Thank you.
Thank you.